Good morning, students. Today let us see functional dependency. Now, it is a relationship that exists when one attribute uniquely determines another attribute. It is a set of constraints between two attributes in a relation. If R is a relation with attributes x and y, functional dependency can be expressed as x tends to y. In this functional dependency, x is determinant and y is dependent. X uniquely determines y, or in other words, y is functionally dependent on x. Now, let us see an example. Now, the student is a relation, ID, name and date of birth are the attribute. The functional dependencies for this relation is ID implies name, ID implies date of birth. Here, if every attribute of a relation R is dependent on a particular attribute, then it is called as primary key. Now, let us see trivial functional dependency. Now, consider relation R which is having three attributes x, y, z. A functional dependency x implies y is said to be the trivial functional dependency if and only if y is a subset of x. In other words, if RHS of some functional dependency is a subset of LHS of the functional dependency, then it is called trivial functional dependency. xy implies x or xy implies y. Now, if suppose nothing is common either left hand side or right hand side, then it is non-trivial functional dependency. Let us see F plus closure. Given a set of functional dependencies F, there are certain other functional dependencies that are logically implied by F. If A implies B and B implies C, then we can infer that A implies C. The set of all functional dependencies logically implied by F or determined by using the given set of functional dependencies is a closure of F. Now let us see the very important 6 important rules. The closure F plus can be identified by applying the Armstrong axioms. The first one is reflexivity. If beta is a subset of alpha, then alpha implies beta. If alpha implies beta, then gamma alpha implies gamma beta. This is augmentation. If alpha implies beta and beta implies gamma, then alpha implies gamma. This is transitivity. We can further simplify manual computation of F plus by using the following additional rules. If alpha implies beta and alpha implies gamma, then alpha implies beta gamma. It's union. The vice versa of this union is decomposition. If alpha implies beta gamma, then alpha implies beta and alpha implies gamma. The last one is pseudo transitivity. If alpha implies beta holes, then gamma beta implies delta holes. In that case, alpha gamma implies delta holes. Right? Based on these 6 rules, let us see an example. Let us assume that R is a relation having 6 attributes, and given the functional dependency, let us compute the closure. Now, my dear students, so you can find here that A implies B and A implies C. So, we can say A implies BC. So, this is our second rule. And we know A implies B, B implies H. So, I can say A implies H. So, this is my first one. Now, since it's given CG implies H and CG implies I can say CG implies HI. So, the first 3 are easy. Now, let us see the next one. Now, using the augmentation rule, A implies C. Right, so I have here CG, so I should convert this into CG, so I should add G on both the side. So A implies C, I can even say that AG implies CG. So by transitivity, okay, AG implies CG, then I can say CG implies I, then I can say AG implies I. Now next is, I have now already AG implies CG now, and you have another functional dependency CG implies H. So in that case, AG implies H. That's all. Thank you, students.